Alan Hall, President and CEO of WeatherGuard Lightning Tech, here to talk about the 4 lightning issues that are created by blade aerodynamics. We want to get the maximum amount of power out of each blade on each rotation at low winds and at high wind speeds. We're driving to greater and greater efficiencies on those blades, and that means better aerodynamics. But that comes with a consequence on your lightning protection system. So we want to make a great LPS and a great aerodynamically powerful blade. How do we do that? Well, it takes a lot of work, but there are 4 issues that are created by the blade aerodynamics today that hurt our LPS systems. Now, number 1 is the flush lightning receptor mounted right on the surface of the blade, which is a very common, probably the most common sort of LPS system used on blades today. We just take a grounded metal object, put it flush with the surface of the blade so there's no aerodynamic inefficiencies around that lightning receptor. The problem with that is that when lightning attaches to that receptor, it's mounted flush with the surface. So all the lightning heat gets shoved onto the composite blade surface, thereby putting a lot of additional heat and eventually melting away, burning away the composite structure around that receptor, and obviously we melt some part of the receptor. So time after time after time after lightning strike after lightning strike after lightning strike, the blade structure around that receptor gets degraded to the point where it has to be repaired fairly often, depending where you are in some parts of the world. So it's important to remember that blades and flatness of the blades is critical, but when you do put that blade receptor flush with the surface, it does create additional damage. You will clearly cause damage to the blade surface when you do that. All right, number 2. Vortex generators. Now, vortex generators are a means of pushing the airflow onto the blade. So where air would typically separate off the blade, we want the vortex generators to push that air back onto the blade, thereby increasing the efficiency and the power produced by that blade. The problem with vortex generators around receptors is, again, if there's a lightning strike to the receptor, and the way the airflow is from off that vortex generator, it takes a lightning channel and it shoves it against the blade surface, thereby heating the blade surface to much higher temperatures than it would otherwise see. Now remember, a lightning strike is roughly 10,000 degrees Celsius. That's the heat of the sun. And anything we do to shove that against our composite blade structure is going to cause heat damage to that blade. So putting vortex generators, which are there for aerodynamic efficiency, also put additional heat into the blade surface and cause damage over time. Number 3, trailing edge serrations, or dino tails, or feathers as they're called in some places. When we put trailing edge serrations on the back end of the blade, we change the shape of the blade, we change where lightning was likely to strike on that blade. And there's been a lot of additions of dino tails and serrations in the last couple of years to either quiet the blade or improve the efficiency of the blade. Those parts, those dino tails and serrations, are plastic, non-conductive. So the thought process is that, well, I put a piece of plastic on the back end of my blade, that won't have any difference on the lightning protection system. The LPS won't even care. The problem is that there is no clean blade. All blades eventually get dirty, and those dino tails and serrations, those trailing edge feathers, will get dirty over time. And when they become dirty, they become slightly conductive. And if they're slightly conductive, they can also be part conductive enough to attract lightning. And when they do, then you get these odd lightning strikes happening in weird places that you otherwise wouldn't expect. So blades that have been modified, where serrations have been added after delivery of the blade, after the lightning qualification of the blade, can cause problems out in the field that were unexpected. So your LPS system, if it wasn't qualified with the serrations, you better take a hard look at it before you put the serrations on to make sure it will tolerate the serrations for the LPS. You don't have unwanted lightning punctures of your blade. Okay, so number 4 is the blade extension. So adding blade extensions increases the rotor diameter, which therefore increases the power generated by the blades. So we've seen a lot of blade extensions over the last couple of years, either a meter, 2 meters. In some cases, it's a winglet extension in addition to the blade extension. So it's two aerodynamic changes. Adding blade extensions changes the LPS system. So the LPS system with the original blade probably had a receptor somewhere near the end of that blade, and then we put on a fiberglass cap and we extend it out a couple of meters and then have some other sort of LPS system out on this extension. You need to be careful about that, because if you have changed the way lightning is attracted to the blade, you may get different results than you're expecting. So the LPS system is part of the blade and needs to be qualified with that blade shape, because the blade shape does matter. So adding blade extensions is a great idea and does produce that additional power you all are looking for, but it probably has changed your LPS system. You need to take a really hard look at it. All right, those are the 4 main lightning problems that come with aerodynamics. If you have questions or you want to learn more about lightning protection of blades and wind turbines, check out our YouTube page or visit our website at weatherguardwind.com.